I handed out this combination practice, and you guys have had a chance now to work on it. If you haven't finished this, go ahead and finish it up, pause this video, and then come back after you've finished, because we're going to go over this. Okay? All right. Number one, well, first of all, the first thing I want to do is to just point out a couple of differences between some of the stuff you've seen with my notation on the board and in the book. When I was talking about permutations, I was using this notation here, where you have n objects arranged r at a time. Your book uses this. Just want to make sure you're aware that those mean the exact same thing. And then as we've been talking about combinations, I've talked about n objects and you choose r of them at a time. Your book will use this notation or we'll use that notation. Those all mean the same thing. So like for number one on that handout that I gave you for combinations practice, it asks you to find out the number of ways that a professor can form a group of 7 students out of a class of 17. Well, that same thing, you can represent that with 17(7) or 17(7). Regardless of how you notate the 17 objects, choose 7 at a time, the result is the same. Okay, because you hopefully remember that this is n factorial over n minus r factorial r factorial. So that's all we're doing here. So that's going to be 17 factorial over 10 factorial, 7 factorial. Okay? 10 factorial divided into 17 factorial, that just means that this is going to end at 11. And then 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 will divide out with this in the denominator. And then you have 7, 6, 5, 4, 3, 2, 1. If you need to calculate that by hand, you can. You can divide this out. 3 times 4 is 12. You got a 6 and you got 2 and a 7. That's 14. So you can divide this out, or just punch this all in your calculator. Do it that way. Okay. Number two. Number 2 says that we have a class of 17. You have 10 computer science majors, 7 math majors, and you want to figure out how many different ways you can form groups of 4 computer science majors and 3 math majors. Okay, so it's like picking sandwiches. Picking toppings for your sandwich. There's 10 computer science students, and you want to form groups of 4, and you have 7 math students, and you want to form groups of 3. So going with 10, choose 4. You have 10 factorial over 10 minus 4 factorial, 4 factorial. And you have 7 math students, choosing 3 of them at a time. Okay? And so this is going to be 6 factorial, so that's just going to be 10, 9, 8, 7. Again, you can punch all this into your calculator, especially if you have a TI, Texas Instrument 82, 83, whatever the case is, 89. You can just go into your probability menu and you can see these combination formulas there. Anyway, so this 6 factorial we can divide out with the 6 here, and that just leaves 4, 3, 2, 1. And then 7 minus 3 is 4, so this is going to be 7, 6, 5. Because the 4, 3, 2, 1 divides out with this 4, 3, 2, 1. And then 3, 2, 1. So this is 6, divides out with that 6. This 8 divides out with that. You can simplify this all down, multiply it out, you got your answer. Okay, number 3. Number 3 says you got 6 questions on a true-false quiz. How many ways can the quiz be completed with 2 true and 4 false? I mentioned this in class, but when you have 6 questions on a true-false, you can, you could flip a coin, right? You could say heads, tails, true, false. So 6 true, false, 6 coins, same thing. But when you have 6 questions and you want to know how many different ways you can get 2 true, or you could say, we want to figure out how many different ways there are to get 4 false. Either way you do this, it's going to be 6 factorial over either 6 minus 2 factorial, or it's going to be 6 factorial over 6 minus 4 factorial, 4 factorial. You'll notice that this comes out to be the exact same thing, because what's 6 minus 2? 4. And what's 6 minus 4? 2. So both of these, regardless of how you set it up, you're going to end up with 6 factorial in the numerator, and then you're going to end up with 4 factorial, 2 factorial in the denominator. 4 factorial just is going to leave 6 and a 5 up here. 2, 1, so the answer is 15. Maybe you remember 15 from our Pascal's triangle. Okay? If you don't, take a look in your notes, look at Pascal's triangle. Look at the row that starts out 1, 6. Look at that 15. Okay. Number 4 on the combination practice sheet. Number 4 says when flipping 6 coins, 1, 2, 3, 4, 5, 6, but in this case we're talking about coins. Coins, true, false, it's like potato, basically the same thing. How many ways can the 6 coins give at least 4 heads? At least 4 heads. What we're looking at here is either 4 heads or 5 heads or 6 heads. Okay? So this will be 6 factorial over 6 minus 4 factorial, 4 factorial, plus 6 factorial over 6 minus 5 factorial, 5 factorial, plus 6 factorial over 6 minus 6 factorial, 6 factorial. That's going to be 0 right there, isn't it? Make sure you know what happens when you have 0 factorial. Okay, do you? We'll get back to that in a minute. When you say 6 factorial over 6 minus 4, that's going to be 2. 4, that's going to leave it 6, 5. So that's going to be 6 times 5 divided by 2 is 15. And then 6 minus 5 is 1. This is 5 factorial. 6 factorial divided by 5 factorial. All that's going to leave up top is 6. 0 factorial? By definition, 0 factorial is equal to 1. So you got 6 factorial divided by 6 factorial, that's 1. Okay? And so you got 15 plus 6 plus 1. That is the number of ways you can flip 4 coins and get at least 4 heads. 15, 6, and 1 is 22. Back to Pascal's triangle. Remember that 6th row of Pascal's triangle? I hope you remember how this is set up. Right? Yeah, that's the 6th row of Pascal's triangle. Let's move on to number 5. Grab another piece of paper here. Number 5 says, in the expansion of x plus y to the 6th, the question is, what is the coefficient of x to the 4th y squared, then also what is the coefficient of x cubed y cubed? Well, if we're trying to figure out x to the fourth y squared, the way we do that is we figure out 6 choose 4. And if you just look back at the previous problem that we just finished up on number 4, 6 choose 4 turned out to be 15. Okay. If you want to figure out the coefficient for x cubed y cubed, we're going to need to calculate 6 choose 3. And again, if we want to write that out, it's going to be 6 factorial over 6 minus 3 factorial, 3 factorial. 6 minus 3 factorial is 3 factorial, so it'd be 654 divided by 321. That's going to give you, you can calculate that out, that's 20. Okay? That's number 5. Got the coefficient. There's the coefficient for x squared y squared is 15, and the coefficient for x cubed y cubed is 20. Number 6. In the expansion of 3x minus 5y, what is the coefficient of xy to the fifth? Well, let's do this in 2 steps. If it was just x plus y to the 6th, and we were trying to figure out the coefficient of xy to the 5th, the coefficient on x is 1, the coefficient on y is 5, so we would need to figure out either 6 choose 1, or we could figure out 6 choose 5. And again, go back up to number 4, and you can see that the answer there is 6. All right, so the coefficient, if it was just x plus y, the coefficient for x to the first, y to the 5th would be 6. So we've got 6 x to the first, but in this case x is 3x. And y to the 5th, what is it that's being raised to the 5th power? Negative 5y to the 5th. This is what we got to figure out. Okay? So let's pull all the coefficients together. You got 6, 3, and negative 5 to the 5th, and you got an x, y to the 5th. Multiply this out. 3 6s are 18. Negative 5 to the 5th power. You can do that in your head or grab a calculator. That's going to be negative 3,125. Yes, I figured that out ahead of time and wrote it on my notes here on the side. And I also figured this one out. If you multiply 18 times 3,125, you get 56,250 xy to the 5th. Good grief, that's huge. So instead of multiplying this whole thing out, 3x minus 5y to the 6th, we just know that using this combination here, the coefficient on the x y to the 5th term is going to be 56,250. Okay? All right. Number 7. This is the last one. This is our baseball question. Okay? Let me start on a new clean surface here. Simple enough. Number 7. In his prime, Babe Ruth had a batting average, we'll call that B. He had a batting average of 0.363. So that's his percentage, his hitting percentage. He had a 36% success rate at the plate of getting a hit. Well, if his batting average is 0.363, then how often is he, and again, for those of you that are baseball fanatics, this is an oversimplification, but if you don't get a hit the probability of not getting a hit is going to be the other, the remainder of 100%. So if it's 0.363 is the batting average, then the probability that Babe Ruth does not get a hit is going to be 0.637. Add these two numbers together, you get 1. Okay. So the question in this one, in his prime, Babe Ruth has a batting average of 0.363. In a game when he has 5 at-bats, what is the probability that he gets 3 hits? Well, if he's going to get 3 hits, that means he's going to miss twice. So what we're trying to figure out is 3 hits, 2 misses, or in this case, B cubed M squared, right? Because he's going to get 3 hits, right? His batting average is 0.363, so that means his missing average is 0.637. We need to figure out what the coefficient is for this term, okay? Because if he's up there for 5 hits, we know his batting average and we also know his missing, 0.637. So we got to figure out the coefficient for B cubed M squared. Okay? In other words, we got to figure out 5 choose 3. Or because of the symmetry that you're seeing in Pascal's triangle, we can figure out 5 choose 2. Either way. Okay? So 5 choose 3 is 5 factorial over 5 minus 3 factorial, 3 factorial, or you could do 5 factorial over 5 minus 2 factorial, 2 factorial. Either way, regardless of how you do this, you're going to end up with, in the numerator, 5 factorial. In the denominator, you're going to have 2 factorial, 3 factorial, or 3 factorial, 2 factorial. Either way, it all comes out to be the same. This is going to be 10. Okay? So that's the coefficient on this term, 10b cubed m squared, which is 10 times 0.363 cubed 0.637 squared. Punch that in your calculator, work it all out, and you get 0.194. There is just a 19.4% probability that with 5 at-bats, Babe Ruth is going to get 3 hits with a batting average of 0.363. Okay? The second part of the question says, instead of just asking what's the probability that he gets 3 hits, the question is what's the probability that he gets at least 3 hits? Well, that means 3. Let me slide that in over here. That means he gets either 3 hits or 4 hits or 5 hits. Okay? We just figured out the probability of 3 hits. That was 5 choose 3 times B 3M2. Or with 4 hits, that would be 5 choose 4 B4M1, or 5 choose 5 B5M0. Okay, so you just put in for B, you put in 0.363, you cube it, we've already done this, 0.637 squared, and then you're going to go 5 choose 4 0.363 to the fourth, 0.637 to the first, plus 5 choose 5, and then you add all that up, and that'll give you the answer for at least 3 at-bats. Sorry, for at least 3 hits with 5 at-bats. Okay? Go ahead and figure that out. Maybe we'll get the answer when we're in class again. All right? So there you go. That is all of the solutions, minus a couple things I left you to work on for this combinations practice.